69, enzyme supplementation to increase value of soy hulls at finishing pigs. This paper comes from Illinois State University, and Schertz will present this paper.
Thank you everybody for being here. My name is Libby Schertz. I'm a graduate assistant at Illinois State University with Dr. Examiners in Normal, Illinois. The current project we're working on now, we're interested in unlocking the potential nutrients of soybeans. And more specifically, our project is titled Enzyme Supplementation to Increase Value of Soy Products Fed to Finishing Pigs. I'm here today to just kind of walk you through the research and what it involves, why you should be of interest in the soybean community, and what the implications are about the future. So first off, what are soy hulls? The soy product of interest for this project is soybean hulls, and basically a soybean hull is the byproduct that is left over when soybeans are processed. In other words, they are the shell of the soybean. Because of the increased demand for higher analysis soybean meal in diets, soybean hulls have become widely available throughout the United States. They are light, flaky, and bulky, and they have a crude fiber content of 35 to 40%, which is quite high, and also a crude protein content of 11 to 12%. So why soybean hulls and why should we care? First, as I discussed, they're widely and readily available. Secondly, they're an inexpensive alternative feedstuff. And this chart here reflects the price of corn, soybean meal, and soybean hulls in dollars per ton. And as you can see by comparison, soybean hulls have the potential to be the most cost efficient. So some things that create obstacles when we work with soybean hulls: they're very high in non-starch polysaccharides. This is basically a large carbohydrate that is not digested but rather fermented in the large intestine. So in other words, non-starch polysaccharides are essentially fiber, and these fibrous compounds are found in cellulose or cell walls within the soybean hulls. Therefore, non-starch polysaccharides are the most abundant carbohydrate in nature because cellulose is everywhere. But however, the problem is soybean hulls are so high in fiber that they're normally poorly digested by non-ruminant animals such as swine. Therefore, the energy contained in these abundant non-starch polysaccharides within soybean hulls is relatively unavailable to the pig. This creates a hurdle for swine nutritionists because there is an alternative energy source with the potential to be unlocked. Soybean hulls could be a key ingredient of interest in the formation of diets that are inexpensive by comparison to standard industry diets, but still have the capability to provide proper nutrition for swine growth and maintenance. So the proposed potential solution to this problem: firstly, we know that it is standard practice to add the enzyme phytase to growing and finishing swine diets. Phytase is known to increase the availability of phosphorus to the animal. By extending this concept and adding enzymes with protease and carbohydrates activity, there is a potential to unlock energy utilization of these high fiber diets. Fiber is virtually indigestible by naturally occurring animal enzymes, so exogenous enzyme supplementation should be explored and is being explored currently. However, the results have been inconsistent, and therefore further research is definitely warranted. Adding an enzyme with protease and carbohydrates activity will potentially increase the utilization of fibrous components of soybean-inclusive diets. Which leads us to the current study. This study intends to evaluate the combined effects of soybean hulls and exogenous enzymes on finishing pig performance. It is done in cooperation with Southern Illinois University, and the results presented are part of a larger project. So please note that this is a preliminary trial and is part of an ongoing research project at Illinois State. So the trial used 8 pens, and they measured 4.2 by 2.8 meters, which is about 13 by 10 feet. This allowed for 4 pens of barrows and 4 pens of gills. Each pen contained 2 water dispensers and a single 3-compartment feeder, and these pens were side by side in a mechanically ventilated conventional finisher arm. Pigs were separated into pens by groups that gave an average pen weight so that all pens were as similar together in value as possible. The average pen, for your reference, started at 156 pounds and finished at 238 pounds. Here is a picture of an example of the pens that we have. You can see the water dispensers and the single 3-compartment heater. So this shows our diets. Our diets were fed in phase and followed NRC 2012 nutrient recommendations for swine. There were 4 diet treatments that we used. They were assigned randomly to the 8 pens, so this allowed for each treatment to be replicated on 1 pen of barrels and 1 pen of ales for comparison reasons. All 4 diets were equal in standard ileal, digestible, glycine, and metabolizable energy ratio. The control diet was a corn soybean meal diet that included exogenous phytase. The soybean hull diet was also a corn soybean meal diet that included exogenous phytase, but it also included up to 20% soybean hull content. So as you can see here on my chart, soybean hulls replaced a portion of the corn and soybean meal. So here's our 3rd and 4th diet, which would be the control plus enzyme, which was identical to the previous control diet, but it also included a commercially available enzyme with protease and carbohydrates activity that we added to the diet. And the same concept here with this last diet at the very end. It was identical to the soybean hull diet from the previous slide, but it included a commercially available enzyme with protease and carbohydrates activity as well. This just gives a nice little summary of the 4 diets, so you can see them together for reference. We formulated these diets to produce the best possible scenario for comparison among treatments. So throughout the trial, to maintain the integrity of the results, certain measures were taken to ensure the validity of the results. Pigs were checked daily to ensure health and performance, and during pen checks, feeders were kept full and the pigs were fed ad lib, and waters were cleared at all times. Furthermore, the weights of each pig was collected every 14 days on a scale and tracked to track the progress of growth. For the analysis for this trial, we collected data and analyzed using a statistical program called SAS, and the analysis of variance, or ANOVA, was used to look for differences among 4 dietary treatments. The experimental unit that we used was a pen of 12 pigs, and the results were considered significant at a p-value of greater than 0.05, and the model was set to analyze the 4 dietary treatments that we used. Here is a summary of our results. As you can see, these p-values are shown to be not significant. However, as you can see later on, there are numeric differences that suggest trends in these results. I'll show you in the next slide. Again, I would like to point out this is a preliminary trial and it's the first of 3. So this is promising for future results. Average daily gain, average daily intake, and gain to feed ratio were not impacted by the dietary treatments, according to our statistical results. However, numeric trends are suggested within the data set. We are limited by a small sample size at Illinois State, so a lack of statistical significance is to be expected. However, these results imply that further research should definitely be beneficial.
How did you get the enzyme prior to your experiment? or did you get it from the literature review, or did you have a screening method prior to experiment?
So are you asking how we decided what level of enzyme to use?
Not level, but how did you choose this kind of enzyme?
It was the enzyme that was commercially available in our area that had protease and carbohydrates activity that we could use in diets. It was available.
Other questions?
On your table of results, I don't know if you're in the back of it looks like your overall performance for like average daily gain and gain of food are better for the diets without soy milk. So is there any counterproductive to what you're wanting to see?
What I was hoping to show through this this slide here, that the diets that had enzyme supplementation tended to do better. So even though that our overall results are not significant, we're hoping that future research will expand on this idea that adding enzymes will help with the energy utilization in the diet.
Yes.
Are soy hulls that commonly used in big diets?
Not at high levels, especially since we use 20%. It just hasn't, the results